Yeah, we discussed about what exactly the computer vision is all about, and what is the applications of computer vision, and also we discussed about the difference between image classification, image segmentation, object detection, and so on. Let me see any issues. Those guys are sending the message again. So, okay, so these are the topics that we discussed, and also we discussed about the difference between those things. Okay, the image segmentation, image classification. You can probably watch my video from the link which I shared. The link which I shared, you can watch it. Okay, so that because this is also one of the important algorithms as part of the deep learning, and the using convolutional neural network. Even in the case of self-driving car, it uses the CNN algorithm. But again, the advanced versions of CNN algorithm, even CNN itself, the convolutional neural network, different different flavors are there, like mask RCNN, RCNN. Likewise, different types of RCNN convolutional neural networks are available. This is the fundamental building block, the convolutional neural network. The whole idea of convolutional neural network is reduce the image size. Okay, extract only the features that are important for us to do the classification. If you want to do anything like image related classification also, then you can go for computer based, the convolutional neural network. Convolutional CNN algorithm is best used for image related stuff like the classifying the images. For example, you are given bunch of images, and so once you train your algorithm with the images, it should be able to classify the moment when you show any new image. Okay, it should classify correctly. So that's what we discussed. And the next one is we discussed about each and every component of convolutional neural network. So we start with the um, convolutional layer, and then we proceeded with the pooling layer, and then followed by the pooling layer, you will have the convolutional layer again. So in the real-time scenario, we'll be using more than one convolutional layer. And each convolutional layer is followed by the pooling layer. Pooling layer is based on, it's used for pooling layer is used for downsampling. Okay, all these things I discussed. Please watch my conventional CNN video from our channel. Okay. And today, what we will do is we will continue with the implementation part. How to implement the convolutional neural network in Python. Okay, how do we implement the convolutional? How do we do the classification? So far we discussed about the second. Yeah. So far we discussed about what the binary classification, regression problem, how to solve a regression problem. When it comes to classification, binary classification, how to solve the binary classification problem. Either yes or no kind of thing. In your dependent variable, you have yes or no classes are there. So in that case, if you train your algorithm with the dependent variable which has yes or no, right? So and then when you apply the trained algorithm on the unseen data, it has to classify the unseen data either yes or no. And also the advantage of the machine learning algorithms are like along with apart from classifying the images are yes or no, it also classifies it also assigns the probability for the classes. Okay, so this is binary classification I'm talking about. Now what we will do is we will take a look at how we can solve a multi-class classification problem. Binary class, this is a multi-class classification. So in the case of multi-class classification, the classes are mutually exclusive, which means a single instance of data can belong to one and only class. That is what multi-classification. So I'll just write it here. See, I just give you an example. Let's say you have given a bunch of images which has something like apple. Let's say you have a column called fruit. a feature called fruit. In that column, you have values like apple, and then you have something called pineapple. Next one is like listen, what other fruits we can say? Yeah, custard apple and banana. So you have in the fruit column more than two classes are there. How many classes? Four classes are there. Four different categories: apple, pineapple, custard apple, banana. If I show any fruit, it should classify it correctly, saying that hey, it is pineapple or apple or it is a custard apple. Okay. So in the case of multi-class classification, the classes are mutually exclusive. The apple is different from pineapple. Pineapple is different from the custard apple. So each class, the classes are mutually exclusive. That means each instance of data can belong to one and only one class. Okay. A single fruit we cannot call a single fruit as apple and pineapple, isn't it? Either we say it as apple or we say pineapple. Okay, in the case, and also we discussed about before, see at the outset of this training program, right? Machine learning part, I discussed about something called multi-label classification. In addition to that, we discussed about multi-label classification problem. A single instance of data can simultaneously belong to two or more classes of target variables. See, in this case, for example, if I show a fruit to my algorithm, trained algorithm, it should classify either it is apple or pineapple or custard apple. That is what multi-classification problem. So at any cost, in this case, it will assign any one of the class to the image which you show it to your algorithm, trained algorithm. Whereas in the case of multi-label classification problem, the classic example is the movie, right? So the movie can be, action oriented, or some movies like, you have something called so comedy come romance movie, comedy and romance. So a movie has you can, so in that kind of situation, right? The movie, if you want to classify it, so that kind of problem is kind of multi-label classification. A movie can have more than one property, right? It can have something like a tragic movie, right? Horror movie, and a tragic movie, and some movies like, the comedy, and you have something like romance, those kind of movies, and number songs, right? Songs will be there. So you can assign more than one label. That is what is called a multi-class classification. The classic example, if you go to the internet, you can see that Netflix. Netflix is a site, it's a video rental site like Amazon Prime. Okay, you can go and buy any movie, or you can, rent a movie there. Okay, if you can go and subscribe for the movie, and then you can watch the movie there. Right. So in that case, they will assign the behind the scenes at Netflix. They are using the multi-label classification or algorithm. So the gender can be crime or adventure or thriller or drama. Okay, and something like that. Okay. There is a movie called Dark Knight Rises. Okay, so in that case, is that crime movie or adventure movie or thriller movie, something like, right? So more than one label we assign it in that kind of situation. So for a single movie, so in that case, that is called multi-label classification. Now what we will do is, as in today's session, we'll take a look at how do we implement the convolutional neural network in order to do the classification. Okay, multi-label classification. To start with, I import all these packages. Let me just check what happened. Okay, so import all the packages. Start with import all the necessary packages. So you are familiar up until these packages, right? You are already familiar with these, but these packages are quite new one for you. TensorFlow, import TensorFlow as TF, and TensorFlow.keras.callbacks, import TensorBoard, and import Keras datasets, all these things. These are all related to Keras. Keras is an API to your TensorFlow. TensorFlow is like a backend. So you know very well Microsoft SQL Server, you know, right? So we install Microsoft SQL Server and then we install SSMS. Why do we use SSMS? Using SSMS, we write the SQL query. The SSML will fire the query to your SQL Server behind the scene, and then you get, you know, it shows the output, right? We don't have to go and write the query directly in the SQL Server. Instead, we are using the SSMS. The SSMS is a front end, and the back end is SQL. Similarly, here in this case, TensorFlow is a back end, and Keras is a front end. Using Keras, we can, it's a kind of an API. Okay, so the Keras basically it helps us or makes the developer's life easier. You don't have to write too many lines of code. Okay, it's a very simple one. Using Keras to implement the convolutional neural network. Now, even in the latest version of TensorFlow, also they made it Google. It's a Google, you know, they released this one. Okay, they made it to open source, and Google in their internal projects they developed a package called TensorFlow, using which you know, they implemented a lot of deep learning and computer vision related algorithms. Okay, so now with the latest version of TensorFlow itself, right, whatever the Keras you do it, the same thing you can do it here also. But you know, any of the Keras is very easy to understand. It makes the developer life very simple, and hence we will use the Keras package here for the demonstration purpose, and will help you to show how we are going to do the image classification using Keras. The backend, but still the some backgrounds. TensorFlow is one of the backend, and similarly you have something also Theano. Theano is another backend. Okay, but TensorFlow is very popular because it's been developed by Google and they've been using it since longer time. With the TensorFlow, the performance is much faster, especially when you do work with the image classification and other image related processing. The TensorFlow, you know, the backend is much helpful. When it comes to performance, it is faster. All right. So now what I'm going to do is in today's session, I will show you. We will take the MNIST dataset. MNIST dataset. Okay, we have something called MNIST dataset. Look here. So we have something called MNIST dataset. Okay. So this dataset is available as part of your Keras. Keras.datasets, import MNIST. Okay. So this dataset is available as part of the Keras package itself. So what, you know, in this dataset, almost 60,000 images are there. And then the training set, okay, and then test set, 10,000 images are there. So in total, 70,000 images are there. It is a subset of larger set available from NIST. The images have been size normalized and centered in a fixed size image. So they did all the things, you know, the image related, all the images should be in the same size. The interview they'll ask you. We have some few images are in some size, and we have a mix of different size of image. Then you cannot use conventional network. First, you need to you know, size the images. All the images should be in the same size. Okay, you need to pre-process those images in such a way all the images should be in the same size. So here what they did, they made our job simpler, where in the case of MNIST dataset, they already normalized and centered in a fixed size image. All the images are in the same size. It contains images of handwritten digits. For example, something like this, 5. So this 5 can be written by, see, it's all handwritten. The, you know, different people, right, customers or people, how they write it. They have taken the screenshot, okay, and then it's something like, you know, they stored their handwriting. For example, some people, they might write something. 1 second. Oh, not this one. I will use something else here. See, I write 5 like this. And you might be writing something like this, right? Some people, they might be writing like this. Some people, different people handwriting. The handwriting varies from one person to one another person. Even if we ask the people write the same letter or the digit. Okay, if I ask you, you will be using something like this, right? Or something like this, 5. Different people use different, the way of representing the 5. But end of the day, all these 5s are same. Okay, but how will the algorithm will get to know if this 5 is different from this 5 and this one? Right, so that's the reason why what we are doing is we are training with more images. In this case, reasonably, we are training the algorithm with close to 60,000 images, 60,000 different handwritings. And then once we train the algorithm, we apply the algorithm or the model, the convolutional neural model, the unseen data, in this case, which is 10,000 images, okay? So what happens is the model has to classify whether, the given image is 5 or 5, 5. Even though the handwriting differs from one digit to another digit, in this case, in this example, I'm talking about 5. Still, it should say, yes, this is 5. If I show this image, it should say 5. If I show this one, it should still say 5. Okay, it should say. That's the reason why we are using 60,000 images reasonably to train the algorithm. In this case, what is 28 cross 28? This is the size of your image. What do you mean by size of the image? Not in terms of bytes or, megabits. This is your width and this is your height. Yeah, correct. Pixel. Yes, Vikram. Karthik. Yeah, correct. This is a pixel, right? So 28 cross 28. Okay. How come how the system can understand the image? The system can understand the images in the form of pixels. Okay. And in this case, 28 cross 20. So this is the image. The height of this one is 28 and width is 28. 28 cross 28. And likewise, 60,000 images are there. So what I did here, I loaded this data, mnist.load data. When you use this command, the data, mnist data will get loaded into like this, a train and train. This is your independent features. Channel is, in this case, it is one. It's a, grayscale image. Very good, Karthik. Okay, it's a, grayscale image. It's 1. The color channel will be 3, but in this case, as you can see here, it's a gray scan, gray color, and the channel is 1. So if you see here, the data will get loaded into, this kind of. So when you give something like this, mnist.load data on the right side of your equal sign, it automatically splits the data, the independent variable and the label data, and the test data, training test data, and then the label test data. Okay, so it will store something like this. And here we just checked, the size of this one. It shows very clearly 60,000 images are there, and 28 cross 28, the pixel size, the height and width. Okay, and here also 28 cross test data. So here, okay, there is a consistency here, not a problem. Next, what I do here is I just want to use the plt.imshow. Imshow stands for image show. In our training data, what is our training data? Say x underscore train. The first element 0. Okay, comma cmap plt dot get cmap gray. Okay, and if I give plt dot show, it shows me in this 60,000 images, the first image of the 60,000 images. Okay, it's a 5. Okay. Next step is we need to pre-process the data. How we do the data pre-processing in the structured data and all, right? So here we need to, so same way we need to do the pre-process data. Because you cannot directly feed the image to your model, right? So it can cause some kind of problem. So what we are doing is we are just reshaping it in this case. Okay, and xtrain dot reshape 60,000 28 cross 28 cross 1 channel 1. This is gray color channel, hence the channel number is 1. And then the test data set, the reshape, we are using it, train reshape, and we just, after we transforming the shape, right? So what happens is, you can see the 60,000 28 28 cross 1. And here also we do the same thing. Okay, this is mandatory. To work with the Keras API, we need to reshape each image to the format m cross n cross n. So you might be asking that why do we need to? Because this is the rule. Okay, this is the this is mandatory. Okay, so when you work with, you need to change the shape of this one. And then next one is the train samples. I just checked it. The training data set, we have 28 cross 1. Okay, and next one is the batch sizes. Here I define the batch size as 128. Number of classes is equal to 10. So here, how many number of images? 10 images. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The number of classes are 10. Okay, number of batches is 128, and the epochs I mentioned is 2. So in the case of machine learning, a parameter often referred to as epoch. Okay, epochs. So it specifies how many times the training set will be used in the learning process. See here, to teach a neural network, we will go through a training set up to 10 times. Okay, up to 10 times, which means that the network will see 60,000 data samples in total. So supposing if I say 10 here, what will happen is, to train my neural network, we will go through a training set 10 times, which means that the neural network will see 60,000 data samples in total, each and every time. Okay, and sorry, how many number of times it has to iterate, right? So let's say 10 times. Okay, yeah, that's the same thing. Okay, how many number of times? Whatever I said was correct. Okay, so how many number of times you want to iterate on the whole training data set? That is what is called the epochs. And how many samples we need to use it for one update to the model weight? That is what your batch size. Okay, so number of classes are 10. So here epochs, see for example, if I ask you whether you have understood the convolutional neural network algorithm. So what you say? I watched the video one time, sir. I need to watch one more time. But when you watch it 10 times, what will happen? You will say, as you watch it, as and when you watch it, right? Let's say first time you watched it, and second time you watch it. When you watch it more than one time, the level of your understanding is improving. Like how human brain needs multiple iterations to learn. So our learning will evolve as we keep read it, right? When you watch the video, my video more than one time, so what will happen is, end of the day, you will be able to understand. Okay, oh, this is what is happening. This is okay. This is how we need. This is how we need to. This is what he is explaining. Right. The same way, machine learning algorithm requires multiple iterations. If you show the images one time, it will not be able to learn the pattern. So you need to use multiple iterations. The more the iterations you use it, the learning will be more. It will learn more patterns. And also each time, what will happen is, for example, if I say two times, we are showing the 60,000 images to the convolutional network algorithm. But what happens is, in this case, 60,000 is okay. But in real time scenario, if you have 1 million images are there, right? So you cannot show each time. Supposing you wanted to use 100 epochs, 100 epochs into the 1 million, how much it will take, a lot of time. The training time will be very, very high. So, and also if you are constrained with the resources like CPU and memory, what we are doing is each iteration, instead of showing 60,000, you show, 128, 120, something like that, batch. Don't show the entire data. So each iteration 128 to 128. Memory, what will happen? First it will go to the memory, 128 images will get trained, and again 128 thing, right? So it will go. For each iteration, what will happen is 128 to 128. For example, iteration 1, first it will show the 128 records. Again, it will show the next 128, next 120 until 60,000 records shown to your algorithm. It will be, in a single iteration, multiple times this will get loaded. The image is loaded one after other, one batch after other batch, to rephrase my word. So that is how it is working. Okay. See, if I ask you to solve 100 quizzes, can you do it in 1 hour time? No, right? but again, you need time. So what you do is, sir, I will do the first 10 quizzes now. I will do the next 10 quizzes tomorrow. Next 10 quizzes, I will solve it tomorrow. Or next 10 problems, I will solve it day after tomorrow. Right? So here, instead of tomorrow, day after tomorrow, what we are using the batches. Each batch will take only this much. If I load the entire 1 million records, it will come. It is kind of a CPU intense. It will take a lot of time to process everything. Your training time will become very, very high. Okay, now you understood the difference between epoch and the batch size and number of classes. Number of classes is 10. In this case, we have images for 10 different classes. 1, 2, 3, 4, 5, like this, 6, 7, 8, 9, 10. So what this algorithm has to do is, at the end of the day, it should be like this. So one image which has the handwritten digit 1, 2, 3, 4, 5, etc. up to 10. So what will happen is the algorithm will assign the probability. For example, 0.25 probability for each and every digit or the image, right? In total, we have 10 classes of images, but each class have a lot of images in it. So here you have something like 0.45, 0.85, not 0.5, let's say no, 0.15, and for 5, 0.75. And for this is what I explained to you as part of the theory, okay, 0.35 and 0.34. If you look at, the probability assigned to each and every class, the class 5 has higher probability, 0.75. Whichever image has higher probability, that means that image belong to, this class, number 5. Look here in this case, the 5. Okay, it will say finally but it will display all the 10 classes along with display the it will generate the probability for each and every class. Okay, for a single image, 10 classes will be there. Against each class, it will assign the probability. Whichever class this image belongs to, right? That one will have higher probability, right? So we can say this way also. That is the whole idea of this convolutional neural network. Because the convolutional end of the day, that is what it is going to give. Okay. Next one is we need to pre-process the data. So we cannot feed the data as it is. Okay. And what we need to do is, that is what I discussed already. You need to do a reshaping it because we are using Keras. Keras works with that kind of thing only. Okay. After, okay, the same thing, I repeated it. Okay. So after you pre-process the data or reshaping your data, the next step is you need to do the normalization, like how we do the standardization, right? So Z-scale. How many of you remember Z-scale? Z-score. Min-max. See, we use only two techniques. Either you can use min-max or you can use standard scaler, right? The standard scaler uses the Z-score technique, and min-max, as the name says, it uses min-max. Okay, but in this case, when it comes to image, the pixel size for each image ranges between 0 to 255. Right. So what we are doing is, instead of using the typical standard scaler or min-max, we simply we divide the images, right, values by the pixels, right, pixels divided by 255. So this way, we make sure that we are normalizing the input data. Okay. The next step is, this is just to check the thing. And the next one is, this is also an important thing. We need to do one-hot encode our target value. This means that a column will be created for each category and binary input for each category. How many of you remember one-hot encode? See, guys, I finished the course. Take 2 weeks break, sit and prepare everything, ask questions in between. You disturb me. Yes, I'm very busy. Come back with question. I told you several times, even I struggled to understand all these algorithms when I studied, 10 years back. right? So struggling will be there, but you need to work hard. Okay. Anyhow, so in this case, what happens is, so we need to do one hot encode for our target. So in the target variable, what happens is, along with the pixel values, here the input variables are pixels. As I told you, the computer can understand the images in the form of pixels. As a human, when we see an image, we can easily make out, because our brain is more powerful and vision is really, God's gift. As soon as we see something, we can say, hey, this is what 5, this is what 4, this is what 4, this is again 5, because the handwriting is slightly different, but still it belongs to number 5 category. Okay, so but the system, when it comes to the systems or the algorithm, how it can understand, how it can make sense, what object or is there in the image. It sees the, first of all, the system sees the images, sees and understand the images based on the pixel values. So in this case, the height of the image is 28, the width of the image is 28. Aruna, for your sake, I'm repeating it. Okay, so height is 28 and width is 28. 28 cross 28, pixels. You can watch my previous video. That's very important. And right, so the pixels, it sees the pixels only. With the pixels, by seeing the pixels, it can make out. Okay, so what we are doing is, even in the case of pixels, we need to do the standardization, data standardization. And then the next one is the binary encode. See, in this case, the input values are like your training data sets, or something like your this one. What is that? The pixels. If you want, and then what is the y underscore train in this case? It's what value stored in the categorical variable. And if you expand it, you can see zeros and ones, 0, 1, something like that. Okay. See, what we have done here is, let me do one thing. I just execute this one. Here itself. Yeah. I just show you what value stored in y test. This is the label. Like in the case of binary classification, the target where we have 0 and 1, right? But in this case, the labels start from 1 to 9. 1 to 9, not 0. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. It'll start from, up to 10, it'll be there. Look at the labels are there. For each and every image pixels, there is a corresponding class here. 0, 1, 2, 3, 4, 5, 6. So what we are doing is, we are converting this one into one hot encode. So now if you see here, the 0, 1, 1, 2, 4, 5, 6 got something like that. So the first image is 0, 0, 0. Okay. And the second image is 1. Okay. That means, 1 means, it belongs. So here it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Is the 9. Okay. Wherever 1 is there, that means that image belongs to 1. Yes, Karthik, you are correct. Right. So wherever the 1 is there, right? So the second image is, it's kind of a, 1 here. What is that here? 7. The second image is 7, and the third image is here. We don't see anything here, and here it is 1, right? So that means 1. Let's say you just think this is digit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one, the 8, right? It puts 1 here. Rest of the columns it puts 0. That means this given image is 8. So the next step is, we are going to see now what we did as part of data pre-processing. We have splitted the given data into training and test data set, the images, and then the training and test data set, we normalized it by dividing the training and test data by the value 255. Next, we converted the target categorical variable, multi-class variable or column, into a one-hot encode variable. So you remember one-hot encode already explained you all, right? So binary encoding, we say for yes, we say 1, for no, we say 0. If I have more than more than 2 categories or classes are there in my target variable. So in that case, we go for one-hot encoding. Okay. So here the next step is, okay, we did the data pre-processing everything. Next step is we are all set to train our convolutional neural network model. So in this case, we are using the Keras sequential model. So we stack layers using the add method in the case of Keras. Okay, and so these are the flow, okay, to implement a model or to train a model in Keras. These are the steps that we follow, or this is the pipeline. Okay, define. First step is we define the model. Okay, well, so in this case, to create a model, what we are doing is we first initialize a sequential model. So basically, it creates an empty model object. So the model type here I mentioned is a model type. So this model type that we'll be using is sequential. The sequential is the easiest way to build a model in Keras. It allows us to build model layer by layer. That is the whole idea of the sequential. Okay, and so as part of the conventional layer, the first step is to add a conventional layer. Now what we do, the conventional layer is the one taking up the input image, right? So what I'm going to do is, after I define the model as a sequential, once I define as a sequential, we can keep add the layers one after another. Okay, the first layer in the case of convolutional neural network, we are using model.add function method, okay, using which we are adding a layer, convolution layer in the existing neural network, the new neural network, conv2d. This is the function that, or method that you need to use it. The first parameter is the filter count. The filter, how many number of filters that you wanted, 32. We start, it's always right, we start with 32. What do you mean by filter? Can someone tell me what do you mean by filter? Last week, those of you attended, can someone tell me what is a filter here? Kernel, very good, right? So filter is kernel. What do you mean by kernel? See, guys, don't postpone it. As and when I train, before you attend the training program, at least one day before, you watch my previous class video and then you attend the session. I will not run away. The reason why I give time to you all is, go through the video and come back here. Okay. So topic, you know very well, right? So I told you in the last session, at the end of last session, so we are going to implement the conventional next session. So what you do, you should have watched my video, at least the theory part. It checks with the matrix value. No, it applies, it slides the filter on your input image. Okay, and then it extracts the features. The conventional neural network, it applies the filter on your input image and then it produces the feature map. The feature map, the output produced by the conventional layer, is much is smaller than your input image size. That is what we discussed, because we are applying the filter. We are sliding the filter or the kernel on the input image, so that what happens is, see, this is what my filter size, 3x3. See, it is so easy to say I'm not able to understand, but if you guys go through the internet, then only you'll be able to understand the worth of this training program. Look at 3x3. So this is 3x3. Row is 3 and column is 3. 3x3 filter. How many filters we are using? It 3 filters. So 3x3 and the filters 3. If I say filters 3, this is the one. Okay, and 1, 2, 3 filters, and each filter size is 3x3. And then stride is 1. What is stride? We are sliding this kernel on top of this image, one cell after another cell. So first it will be slided here, and then it will jump to the next one, and then and then it applies that. Okay, fine. So now we need to tell how many number of filters here. This is the conventionally we start with 32 filters. These 32 filters are not the same type of filter. Each filter is different. Randomly, it creates 32 different filters. And then what happens is the size you need to specify, whether the filter is 3 cross 3. That is what we mentioned here. And then the activation layer is ReLU. So why do we need to use ReLU activation in the case of conventional layer? How many of you remember it? ReLU. Yes. Very good, Karthik. To convert your negative value to 0 and positive to not 1, and any value above 0 will remain as it is. So what you're saying is maybe the applicable to sigmoid function, but the ReLU function is it will convert the pixel value anything less than 0 as 0, and anything above 0, it will leave it as it is. It will not bound it between 0 and 1. If it is bounded between 0 and 1, how will it know which pixels are there? It will not be knowing it. Hence, for that reason, we are using ReLU activation function in the case of conventional layer. And then next one is, right, we create another conventional layer. In this case, what we are doing is we are using 64 filters, and each filter's size is 3 cross 3. Again, we are using the activation function as a ReLU. And finally, what we are doing is we are using the pooling layer. In the case of pooling layer, 2 cross 2, here I have used the max pooling here. What is max pooling and the average pooling? How many of you remember it? These guys, I asked another way to update pooling. Okay, I think that is available in other. So max pooling is the max value in your, after applying or sliding the matrix on your, or the kernel on your feature map, the output produced by conventional layer, right? On top of that, the pooling will be, the pooling kernel will be applied. 2 cross 2, right? So what will happen is after applying this, whatever the maximum value is there, that one will be considered. Okay. And the next one is the dropout. Dropout is to overcome the overfitting related issues. Okay. So for that purpose, the dropout is used. For that purpose, we are using the dropout. Dropout is 0.25. This I will explain a little later, don't worry. Okay. And finally, we are using flatten, right? So once you extract the feature map from your input image, that in extracted input image, again, you are passing it to another conventional layer. And then again, you are applying the ReLU activation function. And then this conventional layer produces an output that is another, it's kind of a much compressed version of your the input image, and also it has more evolved the pattern, right? The pattern from the one layer of conventional layer to second other layer of the second layer of the subsequent layer of the conventional layer, right? You can see some kind of improvement in terms of extracting more. It's something like I gave you an analogy. Let's say you have gone to a mall. It's a very big mall. You are standing at one corner of the mall, and you are seeing somebody your friend is coming from the far. Okay, you are just looking at him. You are not able to make out quickly whether he is your friend or not, but you are making some guesses, right, based on the walking style, his height, and all the things. As he come closer, your understanding improves. The same way, as you introduce more conventional layer, the understanding the pattern very clearly is also improving it. Okay. So what we are doing is the output of this conventional layer, we are applying the pooling, and then the kernel again. Okay, the filter. So what happens? We are taking the maximum values. By taking the maximum values, the image size will get reduced further. And finally, what we are doing is we need to flatten that the output of your pooling layer. The output produced by your pooling layer, we are going to flatten it. Why do we need to flatten it? Because the data needs to be converted from two-dimensional to one-dimensional array. Only then your neural, the typical neural network algorithm can work with the one-dimensional data, because it doesn't work with two-dimensional data. The neural network algorithm works with one-dimensional data. So what we are doing is, the output, after the output is produced by your max pooling, we need to flatten it to a one-dimensional array. And then what we are doing is, it will become, in this case, 64, 64 into 2, right? So what will happen is 128. So two-dimensional become one-dimensional. And then here also we are applying the ReLU activation function. And finally, the dropout. Dropout is main for, let's say, you have more neurons are there. Randomly, we are dropping out some neurons. This is to overcome the overfitting related issues. And finally, we are using the dense layer, right? Here, if you say dense layer, dense means your neural network. And then the neural network, see, this is conventional layer. The output produced by conventional layer, in simple term, it is passed to your neural network. Why are we not using neural network to train our algorithm to do the classification? Because the neural network is a overkill, especially if the image size is very big. And if you use your neural network, what will happen is the number of neurons will get exploded. We don't want the number of neurons to be exploded. And that not only the number of neurons will get exploded, and then the same image, the object in the image, if the, let's say, an object in an image, a cat is there in an image. This is what I'm trying to say. The same cat is located in the other portion of the same image. What will happen is the neural network doesn't have the capability to learn the or identify the spatial dependencies. Look here. According to the neural network, these two images are different. When it comes to convolutional neural network in the convolutional layer, it learns only the features. It learns only like how human. When I ask you what is there in the image, you say here dog is there. This also dog is there. But what you will say, okay, this dog is there on the left side in this image. This dog is there on the right side. But end of the day, if I ask you whether it's a dog or not, you will say yes. Classification. Yes, it's a dog. But neural network, it considers this image as a different thing and this image is a different thing. Whereas because of the convolutional layer, right, it can learn the patterns only, features. Okay, this is the curve and this is the curve and this is the thing. Okay, this is a dog. All we need this algorithm to do is to do the classification. If I give any image, it has to say dog or cat. So in that case, learning the pattern is, the features are more than sufficient. But here, nothing is there. Here, nothing is there. What happens is, it will simply, we don't need this portion. That's why we are using the filter to exclude the features, right, that are not available in the image. Simply, finally, what happens is only it considers this one, only it considers this one. Hence, the image size will get reduced. The pixel size get reduced. Okay, so and then what happens is, once the pixel size get reduced, right? So what we are doing is we are passing the conventional layer output as an input to your pooling layer. Pooling layer again, it applies a filter and then it further reduces your the size of your output produced by your conventional layer. And then what happens is the output of your pooling layer will also be much smaller than the output produced by convolutional layer, and then the output produced by your pooling layer, we are going to convert that as a one-dimensional array. That array we are going to pass it to your neural network. The neural network algorithm will learn from that one-dimensional array. I asked these guys, I don't know where they put all the things here. Anyhow, right, so hope you remember it, right? So first layer is your conventional layer. Second layer is, so the first in the architecture, if you see, input image, and followed by that you have the conventional layer. And then the conventional layer, we apply the filter. And then what we do is we apply the ReLU activation function. And the compressed, kind of a compressed version of your input image will get produced, the pixel values. Again, we pass that as an input to the subsequent convolutional layer, and then we apply the ReLU activation function, and then we apply the pooling filter. And finally, what we are doing is we are flatten that array into a one-dimensional array, because my neural network can learn only from the one-dimensional array, not from the two-dimensional array. And what we do is in the neural network, we are dropping out few neurons. Okay, we don't want to use all the neurons. For example, in this case, you have 28 cross 28, right? So 28 cross 28, how much you'll get? It's a very big number, right? So 28 cross 28, that many number of, we don't need all the neurons. Okay, all I need is if I see that dog image, yes, Karthik, that is what I'm saying. The conventional layer, and these are like hidden layer only, right? The pooling layer, these are all hidden layer only. Karthik's question was any hidden layers are, yes, the conventional layer, you are using more than one conventional, that itself an hidden layer, right? And then you have pooling layer, that is also another hidden layer. And then we do something like padding also we discussed. What is padding? How many of you remember padding? Karthik, I hope you remember it. Padding, right? What is padding? When do we use the padding? See, what happens is when you apply the filter on the image, input image, this input image size will get reduced. Okay. But there is a requirement wherein the output produced by your conventional layer should also be same as your input image. In that kind of situation, in the corner, we put, add 0, 0, 0. That is called your padding. Okay. So this is the one I'm talking about. Okay. Okay. So in this case, it is fine. But when it comes to the handwritten digit, how many digits? I said 9, right? 9 digits or 10 digit. In that case, what happens is now my neural network algorithm has to use an activation function called softmax. Remember that. In the case of neural network, the last layer in the convolutional neural network is neural network. The plain vanilla neural network. That neural network, what we are doing is, see anything, if you see dense, that is nothing but your neural network. Okay. So in that case, what we are doing is we are passing the number of classes. You remember number of classes? We already defined it somewhere here. Num classes 10. That is what this one. Okay, the number of classes is 10. Actually, this time we are not using ReLU, we are using softmax. The beauty of softmax is it converts all your pixels into the form of probability. It converts all the things. See how it converts, that is what I mentioned it a while back. See, for example, you have 1 and 2, 3, 4. These are the digit number, and finally 10. So some images have 1, some images have 2, right? They would have used something with a 2, and some people they use 2, right? So this is these are the classes 1, 2, 3, 4. End of the day, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 0 to 9. Yeah, 0 to 9. In this case, 0 to 9. So look here, the possible outcome is 0 to 9. So what happens is it will assign, neural network will assign the probability, right? So the softmax activation function, what it does is it converts your pixel values produced by your the last max pooling layer. Okay. See, what we are doing is the output produced by the max pooling layer, which is nothing but the pixels. We are converting this a one-dimensional array. The one-dimensional array also has the pixel values, 255, 185, something like that. So how do you know that the 255 with that is 255 something like white, 0 is the pixel 0 is black. see in your image, it's something like this, right? Each this is my image. According to the computer, it can understand the images in the form of pixels. This is how 4 cross 4. The image size is, let's say, 4 cross 4. Right? Each cell is a pixel. If I say here 0 means, okay, in this image here you have black is there, and here you have 255, white is there. But 255, 185, these are the values are available, the available in the output produced by the pooling layer. With this, how you can say whether it's the one or the given letter, the image, right? Given images having the letter 1, 2, or 3. How do you know that? You do not know. So that's where the softmax is playing an important role. It'll convert all your pixels into the probability. Okay, 0, 1, 2, 3, 4. Along with it, it'll assign the probability. So this is 0. 2 to 1 is 0 0.515, and this is finally 4 if it's still, if it is 0 0.68 compared to all the other classes. For the value 4, it assigned the probability as 0 0.68. That means the given image is 4. The given handwritten image is nothing but 4, not the other values. The softmax plays an important. It converts the pixels into probability. Very simple. ReLU activation function. The ReLU activation function. It converts the negative values into 0, and anything above 0 is it will leave it as it is, because pixel value should not be negative, isn't it? The pixel values ranges between 0 to 255. And the case softmax, it converts all the pixels into the probability. Okay, that's it. Next one is if you want to see after you created the model layer, right? This is your network model. Okay, and again architecting the convolutional network is that is where they will expect you to be very good at it. So so now the question is, do we here we have mentioned about 2 conventional layer. Is it okay, or do we need to add 2 more conventional layer? Do I need to have some more addition, or do I need to include 1 more pooling layer or 2 more pooling layer? Can I use max pooling or can I use average pooling? Okay, all the things, you will learn it by experience. Okay, so okay, now what we did, we created the layers in the neural network. We architect the layers. Now we want to see how it looks like. So what is our model name? Model name is model dot summary. When I give like this, it gives you the layer. You started with first conventional 2D layer. Yes, Karthik, that's a very good question. Karthik asked a very good question. If I add 1 more layer, again conventional layer, again pooling layer, as I include many layer, obviously the accuracy will improve. But again, hyperparameter tuning, we need to do it. Okay, blindly we cannot add more number of hidden layers. Hyperparameter tuning we can do it. That we will see it later. With that, we'll be able to understand how many number of hidden layers are there. Okay, fine. So now you want to see the summary, model dot summary. If I give it shows everything in a pictorial form. So convolutional layer, the first layer, the output produced by the first layer is going to be the 26 cross 20 cross 32. So here you might get confused. What is this 32 is all about? Number of filters, and each filter size is 3 cross 3 matrix. Here the activation is ReLU. The input shape is input image. The input image, in this case, what did I say? Right, the input image is the height is 28, width is 28. So 28 cross 28. The input size dim. This we define it only one time. That's all. The input shape. That's all. Why? Because in the subsequent layer, it automatically picks up the feature maps produced or the output produced by the previous layer. Right? So 28 cross 28 cross 1. So if you see this one, the output is 26 comma 26 comma 32. So here you might be wondering, what is this 26 cross 26 cross 2? So we use the formula like n minus f plus 1. What is n? N is nothing but, what is your input neuron size? 28. N, this is your n. N minus how many filters you use it here, right? So what is your filter size? 3. 28 minus 3, how much? 25, and plus 1 bias, 26. Look here, 26 cross 32 filters. Okay, and if you see here, I have used it here. So 320, right? So if you want to see, you need to use something like print 3 cross 3 into 1 plus 1. So here, this is the formula, guys. They will ask you in the interview, how do you interpret how do you interpret the parameters or output shape produced by your conventional layer or each layer? In the case of conventional layer, this is the formula. Kernel size. What is my kernel size? 3 cross 3 into stride. We did not say anything. By default, stride is 1 plus filters plus 1. Okay, sorry, into filters. Here the filters. This plus 1 is the default thing. Okay, and kernel size into stride, and plus 1 is the bias into number of filters is 32. If you do this, you get 320. So that is how this output has been produced. The next one is, if you see here, the 18496. Look here, in this case, the number of filters are 64. And then what happens is the previous layer, sorry, here the kernel size, in this case, the kernel is 3 cross 3. Okay, and the number of filters is 32 plus 1, the bias, okay, into 64. Filters are 64 because here we have used the filters as 64, not 32. And when you do the multiplication here, you get 18496. The output parameter produced by the second conditioner is 18496. Okay. And then in the case of max pooling, it doesn't return any parameter. Okay, it doesn't require any parameter. Even the dropout, we are dropping out this and flatten also, nothing is there. And finally, you have the dense layer 1179776. Look here, 9216 into 1, 926 into, because we are flattening it, right? Since one dimensional, 9216 into 1 plus into 128. This value, you need to specify this value. Okay, 9216 into 1 into this one, you will get this one. These are the number of parameters produced in your neural network layer. And finally, right, so what happens is here, dropout is simply dropping out the neurons randomly. And then next one is the dense layer, the final output. Here the number of classes are 10, the final one, right? The final one is 10. Okay, so here 10 into the previous layer neurons, 128 into 10, how much? 1280, right? So 1280. Since we have 10 classes, each class it adds bias. So 1280 plus 10 is 1290. That's all, guys. And if you add all the values, that is what your total parameters. The trainable parameters are 1,199,000. Non-trainable parameters are 0 here. So here itself, I include the formula and explanation, everything. Okay, with this, you should be able to understand in order to explain in the interview process, or right, understand the output parameter sizes. Okay, how these values are arrived. So based on this formula. So the filter size into filter size, nothing but filter kernel, both of them same. Filter size or kernel size 3 cross 3 into stride is 1. We did not specify, but default is 1 stride. Okay, we did not specify any value explicitly for stride. hence it is 1. Plus 1, the plus 1 is your bias. Into filters are 32. That's all, guys. And finally, what happens is, and we are going to make a predictions. Look here, model dot predict. My model name is model, and then predict, and apply. So I apply the trained model on the unseen data x underscore test and predictions colon 5. So you know very well in the case of so look here 4, 8, 10 for each image it produces the probability for each class, right? So minus 13, E minus 13 is 0.00003. That means almost 0. Even this one is or 0, right? Very, very less. And maybe, this one is not the correct. So this is, maybe that image doesn't have anything or something. And the next step is first we define the model and then we explore the summary of the model. And the next step is we compile the model. So as for the compilation, we specify the optimizer. Okay, you can specify SGD, stochastic gradient descent. Okay, or you can use Adam. Adam is also another advanced optimizer. And then the loss function is categorical cross entropy. Most of my students got stuck up here in the interview. How do you compute the loss? Do you know what is loss? Loss function I'm talking about. We use the gradient descent algorithm to reduce the or minimize the value of your theta or theta 1. Very good, Karthik, right? Loss is nothing but error. Very good. To measure the error, what technique that we are using it in the case of binary categorical variable, we are using binary cross entropy, whereas in the case of multi-class classification, we use a loss from categorical underscore entropy. And then next one is what metrics you want to use it. Accuracy, yes, accuracy. And finally, what I do is now only we are going to fit the model. Okay, now only we are fitting the model. Here what I did, epochs equal batch size already be defined, the training data set, and then the training labeled data set. It is nothing but your one hot encoded value. And then if you pass this one, validation date also we can specify it here. The number of epochs is the number of times the model will cycle through the data. The more epochs we run, the more model will improve. Point. Can you understand this one, Karthik? More the iterations are nothing but, yeah, more the iterations, more the hidden layer, conventional layer, a pooling layer, okay? After that point, the model will stop improving during each epoch. In the case of gradient descent, I explained you, how do you make sure that your gradient descent algorithm, when you need to terminate your, the gradient descent algorithm, when you don't see at some point in time, when you don't see any improvement in the error in terms of minimizing the error, then you can terminate it. The same thing here they mentioned it. The callbacks is something like, tensor board. Tensor board is the back end. The output of this one will be, something, right? It will pass it to your tensor board. And finally, evaluate the model. First, define the model. Second is view the summary. Third step is compile the model. And then fourth step is fit the model. And then the last step is evaluate the model. So model dot evaluate x underscore test where both equal to 0. And we can see the test loss is something like that. The overall algorithms accuracy is very good, right? The test accuracy is 0.985. It's closer to 1, right? It's good. And the accuracy plot also you can use it like this, and loss plot, all the things you can use it. For example, in this case, the predict x underscore test, we are applying the train model, the unseen data, and we are seeing the first output of stored in the variable array, pred of 0. It shows for the first image predicted by this model, has 10 classes, and which class has higher probability value? I think this one, right? 0.9 something, 0.99. But the rest of them are E minus 7, 8, 6, 10. It's all, somewhat closer to 0. I know with this we can E minus 0. Yeah, this is 9, right? 0.99. And what I do is, instead of taking all the value explicitly, I specify x test of 0 colon pred 0. I give like this, 8, 4, 5 plus 5, 10. Okay, and what happens is there is a function called np.argmax. It's a very useful function that is available in your Python, the NumPy package. So here what we are doing is, if you pass the predicted values, your predicted values, right, to the argmax, what it does is, it it displays something like this. Okay, automatically it shows us. With this, we are able to understand the first value, the of this predicted value. My model belongs to, sorry, my image belongs to which category? 7. Pretty simple, right? And if you see here, look here, when you plot it here, you can see 7. The next image is 2, and next image is 2, 1. Okay, so we can plot it. So now we can, with this, we can conclude that my model was able to correctly predict it. Okay, we started with reshaping the image using reshape function. And then what we did, we have converted the categorical values in my target variable as a one hot encoded thing. And then we splitted the data, train and test data set. The next step was, we did the standardization. The training data set and test data set, what we did, we divided it by 255 because it is an image, right? So there is no point in using standard scalar or min-max. Okay, after we normalized the data, the next step was we converted the target variables values into one hot encoded thing. And then what we did, we started defining the layer. Something like you build a house, right? Which one should construct first, which one should construct next, right? So we need to we define the architecture here. And then what we did, using the model summary, we were able to see the summary produced by this one. And finally, what we did, we understood how these outputs were achieved. And the next step is predict. Sorry, next step is compile the model. Okay, here we need to specify the optimizer type, loss, and fit the model. And here, once again, I'm doing it. And then evaluate the model. Obviously, once you train your model, you need to check, right, whether the model is accuracy is really good or not. That is what we have done it. Yes, yeah, Karthik asked a very good question. Can I do the same task using support vector machine? Yes, you can do with support vector machine. But when it comes to huge volume of data, support vector machine is not much scalable. Okay, and also extracting the features, right? So that is possible only with the convolutional layer. It automatically detect the features. What object are there in what object is there in the image? It automatically detect or learn the features from your input image. With support vector machine, it is not possible. Very good question, right? Okay, good. Fine. Okay, we are done with the convolutional neural network model. And then next, what we will do is we will continue with the support vector. See, most of them today did not join. Even I'm feeling literally very tired. I don't know, right? So with this, I'm going to wrap up the session. Sorry, guys. Okay, next weekend, definitely I'm going to complete everything. So I will take some time to walk you through the support vector machine, and then followed by that, we'll the PCA, right? Quickly, I'll in 20 minutes I'll explain you. And then what I will do is the NLP and all I will cover it. Okay, NLP chatbot will cover it. So what you do is this script is already available in my website. You go and download it and start practicing. Okay. Any questions? And also most of the college students, right? Mala, Mukilan, Palani, all of them are attending they are preparing for the exam, right? The semester exam started, because of which they are not able to attend. But any of this upcoming Friday, the exams will be over. And the next weekend, we will continue with the NLP part, right? First, we will start with the NLP part, and then the leftover part, we'll try to wrap it up, okay? So my suggestion is, right before you attend the next week's session, make sure that you are at least you are watching the video which I covered in the recent class. For example, today the class is over, and before you attend next Saturday, right, the session. See, there is no point in taking a roll call, sir. You did not take the class. Don't do project management here. Okay, what I would say, it's an opportunity. See, if you guys are able to pick up, I'll do fast tracking. The other intention is, yes, you need to see, if I ask you what is a filter, you are not able to tell, right? So what is the point in completing the training, right? You try to be, smart. That's what they did at the other batch people. Okay, so what you do is you review at least whatever I covered this batch today, right? You review it. See, today I covered the implementation part using Keras, how we do that. And you see this one and come back with questions. And then the previous batch. So sorry, not previous batch, previous week, I covered the theory part. You watch these two things. Next week, what we will do is first half an hour, we'll have some quiz related to the convolutional neural network, all the things. Don't miss out that, okay? Quick quiz, okay? So maybe that quizzes can help you to recollect or recall whatever I taught you. And also, meanwhile, please watch my video, okay? And then we will complete the NLP also next weekend, okay? So most likely in the upcoming weekend, we are going to wrap up everything, okay? And then I will give you the assignment, and followed by the next weekend, we are going to have the test. So usually what I do is I dedicate one day for the test. Saturday, one day for test, and Sunday is for continuing the classes. Next week, what will do? Only the machine learning. So again, you have 2 more weeks. Next weekend, I will finish it off from my side, okay? And followed by the next weekend, you will have you will have to attend the take up the test, okay? So that test can help you to or it will kindle your thought process. Real time scenarios will be asked, okay? And you see, and also I'll give you an assignment related to image classification, okay? I'll give you a bunch of images, and answer, in the meantime, you solve that, come back with the solutions, if possible before Friday. You just share it. See, everything is available here, right? Everything is available here. Only thing is, you need to specify the image file location. That's all. Okay, and then you need to reshape everything. That's all. Here, instead of 60,000, whatever the number of images or the training is, that number you specify. Test data set, whatever the number is there, right? Number that you specify. That's all. Does it sounds good? Fine. So with this, I'm going to wrap up. Okay. And next weekend, we'll continue with the NLP, all the things. Okay. So there is no, because I see that, you're not able to answer even a single question, right? What is except Karthik? Right. So that's what my concern. Okay. You finish it off, and from my side, I will do it. That's all. Okay. And I will next week, I'll complete it. And followed by that, we will have a test. And meanwhile, you in this week, right? You at least complete the image processing related assignment. I'll send it to you. Don't worry. Very interesting one. Fine, guys. Thanks for joining today's session. And since you don't have any questions, I'm going to wrap up the session. We'll share the video right after the session. Don't worry. Okay.